Glad to be here with you all. This has been a big week in transportation with the passing of the Infrastructure Investment and Jobs Act and the recognition that this investment in our infrastructure, both physical and digital, is really apparent now. We saw that there's $550 billion in new spending above baseline levels that has been now allocated. So we stand in this moment and we invite you to think boldly on where we want to head and what we want to accomplish. At the same time, when change comes at us, it can be both exciting and daunting. And this transformation sometimes can feel a little scary. So today we're going to really share with you some practical examples from two agencies that we've worked with, Kentucky Transportation Cabinet and Colorado Department of Transportation, who've taken those steps, starting from a small step and then really going through that journey of digital transformation. And I'm excited to have with us here two Chris's. We have Chris Lambert from Kentucky Transportation Cabinet, and we have Chris Haas with Google Cloud, who's worked very closely with CDOT. And just to kick us off, so that they can introduce themselves, I'm just going to ask each of them what their favorite mode of transportation is. So Chris Lambert, over to you.
We were doing the key lime pie, but car, yes. Car would be my preferred mode of transportation.
Well, you can share.
We thought we were going to do the pie. So yeah, cherry pie is my favorite. My mom's cherry pie. I love that every birthday that I'm with her. Or not, I'll just get one on my own. My favorite mode of transportation is not a motorized vehicle, it's actually skiing downhill.
Awesome, great. Well, we got pies and we got modes of transportation. So as we get in, maybe we go to the next slide. So a little bit on what we're going to do today. As we think about this journey of digital transformation, we're really going to focus on practical steps of how to get started, collecting what is the relevant information, what's really necessary to collect in terms of data. How do we then turn that data into insight that is useful for operations, for planning, for those who need to make decisions? And then how do we empower the ecosystem? And that could mean the ecosystem within your own agency, different departments, different users, from technical users to executive level. It could mean communicating with legislators. It could be communicating with the public or enabling other service providers. So when we think about this journey of digital transformation, it really involves each of these steps in the journey. So we're excited to share with you two practical examples, because I think sometimes we're up kind of like talking about the visions and the strategies, but today we really want to get into how do you start and go through that journey to really deliver outcomes in a short period of time and things that are really meaningful to the business. So I've asked both our Chris's to share with us their journeys and start with a little bit of that agency context. What are some of the challenges the agency was facing? What were the goals that they had when they started off? What did they achieve and how did they approach it? So you'll hear from each of them on their journeys, and then we'll open it up to questions and I'll follow up with some questions as well. So make sure to put your questions into the chat as you're listening to each of these stories. And with that, I'm going to turn it over to Chris Lambert to share the Kentucky story.
Thank you, appreciate it. Thank you for inviting me to be here today. Let's go ahead and jump to the next slide. Just a few stats about Kentucky. As you can see, our organization, we're spread across 120 county offices. We've got 12 districts. We have about almost 4.5 million people in the state of Kentucky. There's our centerline miles and lane miles. I think we've got one of the larger networks of any of the state DOTs. And just a fun fact about Kentucky, we actually have, so we've got 4.5 million people for population, but we have 10 million barrels of bourbon stored in our state. So we actually have more barrels of bourbon than we have people in Kentucky, which is kind of fun. The next slide, please. One of the challenges, or some of the challenges that we faced, or still face, is our biggest issue probably is that we're a really small team and we try to serve a really large organization. We don't use these terms to describe ourselves, but in today's terminology, our team consists of a data engineer, data scientist, and data analyst. And then we normally have maybe one or two other people that kind of float on and off the team. And we seem to have a high turnover rate with that next person. I think we're probably difficult to deal with. But we're a really small but highly effective group. One of the other issues that we have is this kind of started out as an R&D project, right? So for better or worse, it's still kind of thought of that way. Most of the work in those first few years, back in 2015 or so, it was performed after hours or during downtime. And then, I think some people still see us that way. We still do a lot of that kind of experimental work. But our project wasn't truly adopted as an official project or platform or supportive platform by IT until sometime in late 2017 or early 2018. After kind of proving the benefits with snow and ice operations and things, and I'll discuss that shortly. So during those years, the cloud, we weren't allowed to go to the cloud. So everything had to be on premise. So we started building and scaling all this on-premise architecture. So we started big data back in 2015 with like Hadoop and Spark and Kafka and Elasticsearch. And so after managing on-premise architecture for several years, we'd finally kind of outgrown it. Our developers were spending about 50% of their time managing architecture, in addition to paying for, I think, maybe 3 different service contracts with different vendors to help us manage that infrastructure. So then let's see, the other issue that we had is our IT department and others really didn't have a solid set of use cases or other state DOTs that we could look to for guidance, right? So we didn't have like a lot of documentation or people we could call to say what are best practices and things. So we really kind of learned this on our own. We really learned everything the hard way, just to be completely honest. We made all the mistakes you could possibly make with on-premise architecture and distributed computing. So that was not easy. So those are some of the challenges that we faced. Next slide, please. But we had, as far as our organization is concerned, we had amazing support from leadership. We had a couple people that once we kind of showed them what we could do with fusing data together and processing real-time data, they were extremely supportive. So I can't stress that enough. We had some great support from the State Highway Engineer's Office, from director level positions. And they kind of encouraged us just to run with it. But from the beginning, from the winter of 2014-15, we've always had a real clear vision of what our system needed to be, and that's never changed. Simply put, the idea was to recreate all conditions on the roadway as you would experience them as if you were actually located on the roadway at that point in time. So air temperature, pavement temperature, wind speeds, dew points, what's the Doppler radar, like everything we can, speed of traffic, everything we can recreate, we need to recreate. And then from that idea really came a more formal goal of providing real-time monitoring analytics with a high level of accuracy and precision. And we've stuck to that. And that is our goal and vision even today. So along the way, our team, we've kind of earned a lot of trust within our organization. So we're kind of left alone. We kind of work off to the side. I guess you consider us a data science team. We don't fall under the enterprise data team. We're not in the engineering department. We're kind of a hybrid group of folks that kind of work on big data and real-time processing. And they just kind of hand us issues or allow us to go find those issues in the organization that we would like to tackle and try to make better. We're always seeking out more work, and we get to prioritize our own tasks. And then one of the things that's important to our group is being able to experiment, just allowing people the leverage to say, it's really common in our group to hear someone say something like, hey, that thing you were looking at a year ago, I think I figured that out and I'd like to try it. What do you think? Sure. And then we also allow people to fail. I've always said that if you haven't crashed something lately, you're probably not doing your job. So that's just kind of the way we work. We work pretty fast and loose on things, but again, we're coming up with pretty good results on stuff. So the diagram there, I'm going to go ahead and leave that for your reference. This is actually based on NCHRP research report that Kentucky was represented in, and I actually took part in helping to author. But this is a research report about kind of that life cycle of data, or the use of big data for DOTs. So if you're trying to get started in just big data in general, not just cloud computing, this is a great reference to kind of help you understand, the data lake and processing and setting up ETLs and things of that nature. So it's the guidebook for managing data from emerging technologies for transportation. And again, it's pretty good reference. Let's see, next slide. So I'm sure many of you that have worked with the FHWA, you've seen this diagram on the left, and this is a really useful diagram. We really consider our system to fall under those right two categories, that monitor and assess. And we look at the engineering staff and decision makers to kind of be that other side, to make recommendations and to implement things. But our job really is to monitor everything on the roadway network and assess performance. And we're able to do this by the way that we process our data. All of our data is processed against our linear referencing system. We actually add 47 fields of agency type data to each and every record that we receive. So we've got district, county, route, mile point, beginning mile point, ending mile point, the direction, different timestamps. What time do we process the data? What time do we pull the data? What's the timestamp from the data source? So we add a lot of different fields into each of these records, and that allows for, we've got a lot of people that are experts in their field, but then we're trying to introduce new data to them. And this is a great bridge to kind of make that happen. So we're able to give them information that they understand in the form of district, county, route, and mile point, and then also hand them data that maybe they don't understand yet, like crowdsourcing data from Waze, for example. That's a great one. We're able to introduce this data to them, but then they're also able to kind of see something that they understand with the whole LRS and things. And this keeps them from having to learn brand new methodologies and for analysis. And on our first, over on the right side of this screen, this is actually kind of our first real-time use case for monitoring and detection and things and analysis. We actually developed a incident detection algorithm or process. We're probably on about our 5th version of this thing now. Now it runs in BigQuery. What we do here is we take a report from Waze, like an accident report, and then we look for a thumbs up of 1 or greater, and then we compare that to the speeds of the roadway where that crash report is located. And when speeds are 70% or less of free flow, we mark that as an anomaly, right? So that's a detected incident. That's non-recurring congestion. And we actually send an email to our traffic management center to let them know that we've detected an incident at this location at that time. And that runs every 2 minutes across all 26,000 miles of roadway that we have. And then let's see. And then that same methodology, we're looking at crashes here, but the same methodology can be used for work zones and other things. And that's kind of where we get into some of our other use cases. Next slide, please. So this is one example. We've got situational awareness with maps and things, and maps are great tools. Everybody loves a map. Everybody likes to see the data on a map, and we use a lot of this for decision support. But maps only tell part of the story, right? They don't tell everything. So when you look at an incident like a crash or something, and you see a red line of speed data, it's really difficult to understand. When did this happen? Are things getting better? Are things getting worse? And what other factors maybe contributed to the initial incident? Or is this a secondary crash? It's really hard to tell from that kind of top-down view. And that's where these other types of dashboards with real-time analytics and things come into play. And the dashboard down at the bottom, this is, we've got a detected incident, and we've hyperlinked into this dashboard. And on the left 2 visualizations, those are based on time. So those tick marks are, every 2 minutes. And we're looking at the top part is we've got cardinal, non-cardinal direction. We've got our speed data graph. So you can see in one direction, the speed really drops off suddenly. And we also have at the bottom, we've got crowdsourcing reports from Waze so that we understand when those reports came in and what types they are. And then on the other two visualizations over on the right side, we're actually mapping out speed data per mile point. And then when we started looking at this, of course, you're like, hey, wait a minute, we can also do queue monitoring through the same way. All we need to do is expand those mile point ranges, and we can actually look at queues and work zones. So this type of methodology really translated really well to other use cases. Like I said, work zone monitoring, queue detection, et cetera. And this is kind of the way we think of things now. We get the top-down view with the map, but then we're also looking at this time series data as well. And you put those two together to kind of truly understand what's happening on the roadway. Next slide. So this is just kind of a diagram of our snow and ice. I love snow and ice. It's kind of my favorite use case. I actually work snow and ice. I'm on call 24/7 for roadway weather. I'm a team leader or team captain. And so I love this. And so all of our maybe what you would call cutting edge development is really put into snow and ice. Because if I can make it work during snow and ice, we've got 1,400 trucks. We get records from them every 10 seconds for processing those against linear referencing system. We've got speed data. We've got Twitter. We've got everything. We've got 18 different data sources that we kind of fuse together into our linear referencing system and kind of make all that work together and kind of bring that in front of the user for decision support. And I always tell everybody, if I can make that work, if I can put all that together, then everything else is kind of simple at that point. But love snow and ice. What we've got here is over on the left, you've got all of your people kind of collaborating together inside of our messaging app. And but inside that tool, we also have hyperlinks to all of our other dashboards and our maps and things. So they go out to GoKY's, the public, kind of our 511. We also got a snow and ice decision support dashboard where they go out to find kind of our single point of truth for all of our data. And then we've got all these other things like the Elasticsearch, all those really great real-time analytics dashboards. Data Studio, which is part of Google Cloud, is just fantastic for doing summaries and business intelligence type views of data. And then we've got Gov Delivery for emails, and we've got automated tweets going out for crashes and things. But this is kind of the user experience. We've got all of our data, of course, is coming in from the right side. We've got 150 million records per day that we're processing against our linear referencing system. And right now we've got about 35 terabyte of active data that we analyze on a regular basis. And all of this is powered with just 50 Google functions. We've got ingress and egress functions. So if you think about that, there's probably, about half and half. It's probably 25 coming in, 25 going out. And again, we're able to monitor the entire roadway network using the same process. But this is a blast. Again, I love snow and ice, and I could probably do an entire day on snow and ice and all of our dashboards and after action and all that stuff. And speaking of which, I'm not going to let it go. This is one of our snow and ice dashboards. At the bottom, you can see that we're starting to now tell a story with our data, right? At the bottom of this, we've got some really cool analytics and gauges everywhere. But at the bottom, we have this really cool graph. The pink shaded area is our severity index, and that takes into account things like air temps and pavement temps and wind speed, dew point, et cetera. If you notice there, the actual severity index stays fairly level, but then you've got this other red line that really drops off. That's actually our speed data. That's the miles per hour on the interstate. So as you can see, the speed data drops off severely. It's down, around, 50 miles an hour or so, up or down from 70 or something. But then you also see where we've treated the bar graphs there are our salt usage or total tonnage of salt. So you can see that after applying salt and after our efforts, mobility increases or speeds increase. And that's kind of the way we think about mobility. So this is one way that we're kind of gauging our performance or operational performance. This dashboard is live. So if during a snow and ice event, people will be looking at this in real time and trying to understand where we are with our efforts and what our efforts are, what the results of our efforts are. So that's really fun. We've got about 4 or 5 of those different dashboards there. Data Studio, this is fantastic. This is a kind of a built-in, this is a free Google product. And it reminds me of other business intelligence software tools. And what's great about this is I can, and I love Data Studio. It took me about 6 months to get this thing approved through our centralized IT department, but I can create a data set or a view of data in BigQuery, a really nice aggregated view or something. And then I can link directly back into BigQuery from this tool and start doing summaries and things and like near time or after action type of reports and things for management. We've got about 4 or 5 of these also. We've got road closure information. We've got some speed data dashboards. This one's got, we've also got weather information out here that show like a 24-hour time period of weather data, so you can see the trends and things. But again, just a really great tool that they provide that allows us to dig back into our other data sets inside of Google Cloud. Next slide. This is a little bit more technical if people are interested in what we're actually using in Google Cloud. These are the functions and things that were used. So we pull that data in from any data source, whether it's internal, external, CSV file, JSON, whatever. And then we use cloud functions to kind of power everything and drop all of our messages into PubSub and kind of work through the rest of the diagram there. But so those are the actual Google Cloud features that we're using to process all of our data. And we've spent a considerable amount of time trying to simplify this system and this workflow. And I think we've done a pretty good job. That's a pretty straightforward workflow. It doesn't get overly complicated or anything. So anyway, that's kind of all of my presentation. I hope we have some great discussion after this next presentation. I love what Colorado's doing. I just want to give a shout out before you get started, Chris. Love Colorado's efforts.
Yeah.
Well, thanks,
Thank you,
Chris Lambert. What I am so impressed with when I've heard you present before on our public sector connect as well, you've been able to accomplish so much in such a short amount of time. And it's been like just fun watching where you started off with like the snow and ice, and then you just started like knocking out all these other real-time use cases and analytics use cases so quickly. And maybe before we move to Colorado, maybe if you could just share with us, like, you've been able to accomplish a lot in a short amount of time. And you said you started this off kind of as a little bit of a grassroots effort. How did you get that organizational support to bring it to like the level that now this is what you're using, for assessing conditions, performance monitoring, and, operations teams are leveraging all this? How did you move from that kind of grassroots to like getting that organizational support?
The proof of concept was, again, 2015. This is a long time ago. And what we were able to do is the incident detection. We took the crash data from Waze and we took the speed data, and we were starting to be able to actually understand what was happening on the roadway at any given point, like mile point, right? Take a 2-minute segment of time and a mile point or 1/10 of a mile point, whatever that may be. And we started to kind of recreate these scenarios. So we would go to these, we would go to like an after action meeting where they would talk about the incidents on the roadway, and they do like an incident review every quarter. And every time they would bring something up, I would just pull up our data, pull up a dashboard, and you could actually see, like they would say, oh, the crash started at this point. And so it's a traffic incident management like review. And so I was able to kind of, every time they brought up a crash, I was able to pull that up and I would see data, and I could see where we had detected it actually earlier than what the police report was saying that the crash occurred. So our incident detection was catching things, in metro area, we're probably 8 to 10 minutes prior to the report coming into the traffic management center. And then our statewide traffic management center, which covers a much larger area, but has fewer cameras, we actually catch that record or catch that incident much sooner. And it really varies from situation to situation, but we've caught things 45 minutes prior to the time that it was called into our traffic management center. And once we started showing those type of use cases, and then again, the snow and ice, to be able to truly understand what's happening on the roadway, like how much salt was applied, how many trips over top of this roadway segment happened within this last 12 hours, and to be able to start to show that type of information to decision makers, it was kind of a game changer for them as well. One of our leadership took me out to lunch one time, and he said, "Chris, you don't understand. Like just 2 years ago, we didn't even think this was possible, And now you just like playing around, you kind of made this happen. And I'll make one other point before we transition as well, if I've got time. It's funny because we made this move to the cloud, and it's been great for us. In September, I think it was about mid-September, I think, of 19. We had this Google Cloud stuff approved, and we were kind of debating, do we run parallel systems this year? Is this the winter where we run the cloud as a proof of concept and still depend on our on-premise system? And what we did, we kind of looked at each other and were like, this thing's working. It's been working for a while, and we've not had any problems. And it's pretty simple. So about mid-September, we made the decision that we were going to go ahead and transition for that winter onto the cloud, just pull everything up. And you got to understand, our deadline for snow and ice is actually November the 1st. So we have to have everything in place by November the 1st. And so from the mid-September, our developers started working, and I started redoing dashboards. They were moving our real-time data pipeline up there. And by October the 15th, we were actually complete. So we had all of our real-time data pipelines processing. Now, we didn't have historic data up there. We hadn't done that move yet. That took us another month to get historic data up there. But we had all of our real-time data getting processed and everything in place, and dashboards available and all that stuff, so that we actually, that winter, this last winter, 2019 to 20, was our first year just doing complete cloud-based computing and cloud-based monitoring, and no failures. There was a couple other vendors that failed. We had, but it wasn't. That's not Google's problem that a data supplier went bad. But so we made the transition in about 4 to 5 weeks. We completely transitioned our entire architecture to the cloud, and that was pretty cool. And we didn't do it with VMs. Our guys took their Python code and again created a bunch of Google functions to do the same stuff. And then I think we only had to move like one VM, and that was the VM that does all of our snapping, the actual processing. And so within 4 to 5 weeks, we were completely transitioned, and we've been shutting down servers. I think our last server was shut down about 2 months ago on premise. So we're completely done with our on-premise architecture.
Wow. Well, thank you for sharing that. I heard like showing people the value, right? Showing something that's meaningful, it was really important. And then the speed to delivering things. I think both of those things stood out. And I love, you have such a practical approach. And I think that's really helpful for so many other agencies who are in the midst of figuring these things out. So thank you so much.
Sure. Thank you.
And now we'll transition over to Colorado. So we have Chris Haas, who's been working closely with CDOT for the last few years, who has a lot of experience in this transformation, knows our Google capabilities super well, and also connects well to the needs of transportation agencies. So Chris Haas, over to you.
Yeah, thank you, Monali, and thank you, Chris. Always good to listen to your story. I love the grassroots style that you took, and now KYTC has gone all in, which is great to see. First, full disclosure, I'm not with CDOT. I'm a Google employee. I work very closely in our partnership with Colorado Department of Transportation. And I'm saying this only because this is coming from the Google and my point of view and my experience working, partnering with CDOT over the last few years, and knowing what we've been building together with CDOT. So just take that as a grain of salt. This is coming from my point of view and not CDOT's. CDOT's very happy, all the DOTs I know, all very happy to share amongst each other. So please reach out to CDOT if you would like to learn more specifically around what they're doing. Like, for example, I don't have a lot of visualizations to show you, but they would be more than happy to kind of walk you through a lot of the stuff that Chris just showed for Kentucky. The next slide. Just high level. This is just straight off CDOT's website. Very similar to Kentucky. They manage lots of roads. Not the largest state, but they're a large state, but they have a lot of complexities that a lot of states don't have. Kentucky does, actually, but a lot of the other states don't, with lots of mountain passes, mountain highways they need to deal with, lots of inclement weather, both in the summer. This past summer, there was lots of flooding that shut down I-70 through Glenwood Canyon. If you weren't aware of that, CDOT had to manage all of that. And then in the winter, obviously, inclement big snowstorms coming through that they need to deal with and constantly be plowing. So, lots of mountain passes to manage, lots of lane miles to plow on a routine basis throughout the winter, and then just a lot of the maintenance they do. And then like every DOT, they manage lots of funds, both funds given to them from the state, but also federal grant funds that they have to manage to deliver things like safety on the roads, ensuring that the roads are all safe. Go to the next slide, please. So first, just what are some problems? Just high level, what were the two big problem areas that CDOT was looking to solve by adopting cloud technology? One was just an exponentially increasing amount of data coming off the roadways. I mean, just the data from the ATMS itself, streaming and maintaining that data in an on-prem environment was becoming a maintenance nightmare. Just too much data to manage. They continuously had to offload data. A lot of times that meant deleting the data, which isn't always something that you want to do, but needing to do it just because you don't have the storage capacity. The other was just an insatiable demand for data across the agency, but the supply wasn't there. And what I mean by that is they had the data, it was just all very siloed and owned by individual teams, and people either weren't aware of it, couldn't get access to it, or if they could get access to it, it was very cumbersome to do so. Requests to a different team, generally some sort of like batch dump of data that they would then use, but not a continuous stream of data into a platform that they could really take advantage of and analyze it for all the things that DOTs do day in and day out. So some of the goals with adopting a cloud platform, Google Cloud Platform, the first one was really just wanting to be much more data-driven in their decision-making. So they wanted to turn that raw data into knowledge and actionable knowledge, things they could just really take advantage of right away. If they were having real-time insights coming in, real-time data that they could transform into real-time insights coming in from the ATMS, they wanted to be able to take advantage of that and make decisions for things like incident management. Be able to, like Chris just pointed out, the quicker time they can get information around when an incident occurs, leveraging Waze data as well, the better for them, because they need to understand what happened in the incident and then respond to it quickly, and then make sure that if people were injured, that there was response teams coming to help the crash, people that are involved in the crash, if it was a crash, and then clear the roadways so that you can get the roadways back to free flow. They also wanted to continually have improve their commitment to operational excellence. And one clear way of doing that is taking advantage of the immense amount of data that DOTs have and being able to make that data actionable so they can operate more efficiently. And it really is the union of both the people they have, the subject matter experts they have, the traffic engineers, the operations engineers, the tools they can use to make better decisions, and then the processes. It's the union of these three areas that really deliver on operational excellence. And the cloud, adopting the cloud really was able to help accelerate that for them. And then moving from more reactive to more proactive ways of operating. So meaning if you can be predictive, leveraging historical data in what may happen on the road, what may happen when storms are flowing in, then you can be more proactive and you can take better advantage of the resources you have to make sure that the roads are safe and flowing as freely as possible. So what did CDOT achieve? One, they've implemented many use cases. So dozens of use cases. As some examples, secondary crash analysis, statewide secondary crash analysis, and I have a couple of slides that dive into that in a moment. But also things like travel time predictions, travel time reliability, standardization of data. So lots of these data systems and third-party data sets, they don't necessarily have the data in the exact same format so that you can really collate them together. So coming up with a concept of a standard, so road network translation, for example. What is a road segment? What is a road segment from one data source to another data source? Are they the same? If they're different, it's really hard to understand how the data might work together for various types of analyses or situational awareness visualization. So coming up with that concept of a standard and transforming everything to align to that standard. And then also implementing algorithms for variable speed limits, and then data exchange. It's a big component of what I'll show in a moment in a slide, but things like connected vehicles and enabling, with the CV program that CDOT has, enabling a connected vehicle data exchange for them to be able to interoperate with that data coming off these connected vehicles, both that are currently on the roadway and then what we know is coming in the future from all the OEMs. And just a high-level visualization of what we built. Two main things that advanced data analytics platform that's really the core of everything they're doing, from processing, storing and processing their data, and then applying AI and ML where applicable to solve use cases across the agency. But also the need to have a system that can real-time or batch ingest data from any source, third-party and on-prem data sources like an ATMS, and other systems can subscribe to that data, systems and people. So ADAP would be one example of a system that subscribes to all data, but it could be also the ATIS that subscribes to data that they want to publish on the website and through the mobile app. So a little just quick couple slides on secondary crash. So just an example of use case that we solved. The idea here was CDOT wanted to understand if there was a broader definition of secondary crash that they could apply and invalidate. So for example, secondary crashes that occur miles further out than what the current definition of a secondary crash is, or a time frame, further time later after a primary crash, can they equate a secondary crash to that primary crash? And using graph databases in Google Cloud, they were able to see the thread from a primary crash to the secondary crash, and then link those two to understand that these had a relationship, and then they could analyze that to understand what may have been the causality between the primary and the secondary crash. And just go to the next slide, please. To show the power of the cloud, we took what CDOT was already doing in their on-prem systems and with their experts. We put that into GCP, and you can see the benefit they immediately were able to receive from the scalability of the cloud environment. Just be able to process statewide secondary crashes for across 8 years of data in under 2 hours, compared to what it normally would have taken them, which is really just something they couldn't do. I mean, to wait that long for this type of analysis, you just generally wouldn't do it. So you whittle down your analysis to maybe a corridor versus the whole state. But now they're able to do this in a fraction of the time. And then one other thing that, as far as like achievements, data gravity always can lead to other things. So by ingesting immense amount of data into their environment and being able to process that, it led to other decisions around things like running their ATMS in the cloud environment so that it was near to that data. So it could both publish data from the ATMS into that environment and then subscribe to data in a much faster way. And they could also modernize that environment because now they had products that were available to them in the cloud that they didn't have on-prem. So what was our approach? How did we partner with CDOT? How to partner adopt the cloud platform? It really was a phased approach. So we've been working with them since 2018, and they scoped their implementations to about a quarter in length. And they prioritize use cases that they want to solve in that quarter or so time frame. And they really look at this as a journey. So it's not just one phase and done. They're implementing this infrastructure. They're solving use cases on a quarter by quarter basis using a very agile process. So 2-week sprints, and deploying a use case with some sort of visual output or demo so they could demonstrate the value of what was developed, and then moving on to the next one and then planning for the next phase. They had lots of executive stakeholder buy-in, which is critical. Our initial project with CDOT started with the director of ITS, mobile operations, and his vision for leveraging data broadly for mobile operations and what they needed to do. So that's just a critical thing you need to really think about when implementing these types of programs. And then I already mentioned this a little bit, make it digestible. If you implement a use case, you solve a problem, make sure there's some sort of output that you can show the value of it to executive leadership, to peers, to other teams. It could be a simple situational awareness visualization, like in Data Studio, like Chris was showing, or it could be just some demonstration of the analytical output. And then always have a plan to move to production. So operationalize what you've done so that the teams can actually take advantage of it on a day-to-day basis. And I kind of mentioned this in secondary crash, but build upon what you've already done, which is meaning you are solving a lot of these use cases already. The cloud can help speed everything up that you're already doing. So leverage what you've done, see how you can utilize that in the cloud platform. So how did the technology really help here? It really comes down just to the hyper scalability that you can get from Google Cloud Platform. The idea that you can ingest in real time billions of records in a day and you can store really as much as you want. So in the case, CDOT, there are hundreds of billions of records at this point stored in their cloud platform that they can then analyze in minutes or hours. And then just one destination. Instead of having to go to all these siloed solutions, those are your systems of record. They still exist, but you can now go to one place to really get all of that data and really derive the value from the data that you need to from that one location. And then finally, the last slide, if you could move to that, please. It's really just the extensive analytical capabilities. So, right, we're ingesting data in real time. We're storing that data for use and analysis in various ways. And then just having these capabilities that they didn't have before, these analytical capabilities. This could be just querying the data and collating those disparate data sets together. And it can really lean quickly into leveraging AI and ML where it works, so you can be much more predictive in the way you're operating than you could in the past. And thank you for the time.
Great, thank you, Chris. Maybe a question for you, as in talking with different agencies, sometimes like getting started feels a little bit daunting, right? And so how did you all work together, with CDOT and the Google teams to prioritize like where to actually start in having like kind of a bite-sized chunk or a really big scope? How did you figure that out and manage that?
Yeah, so I would say we had some luck. We had a very visionary ITS director who had the budget, had the authority, and knew what he wanted to implement, and came to us really because of not just because of our platform, but also because of Google Maps and Waze. Just the fact that those were platforms they took advantage of, and they said, okay, well, we have this more holistic view of how to analyze traffic information and visualize it and provide it back to the public and to the agency. And so we were able to work with him to really identify and prioritize use cases that were important to them. The other thing I would say is I love, and lots of government agencies do this, but I really see it in the DOT space. You're all very willing to share with each other. And I think that really helps in adopting things like this, because CDOT was seeing what other DOTs were doing with cloud technology, not just necessarily Google's, and wanted to do the same thing. And so that they could leverage what other peers have done to learn from them to then help them prioritize use cases and move forward.
Great, thanks. Hey, Chris Lambert, I'm going to go to you. One of the things that I think is happening now that we're hearing about is there's staffing and labor shortages, and that's becoming an issue for agencies and many sectors, as we're hearing in the news often. Maybe you could share with us, how does technology help address that and maybe take on more scope with less staff, or have you found that to be the case as you all have been working?
Sure. Yeah. Snow and ice is a great example. Everybody's trying to do more with less. And so we've got we were doing some research with University of Kentucky. They've been doing some route optimization work. A lot of that happens offline, but now we've got route completion tools and some other things we can use. To give you an example, like we have a prioritization A routes. We have different route prioritization. So we've got A routes, and they're cleared every 1 to 2 hours. B routes are every 4 to 6, and C routes are every 10 to 12. Having that awareness and that time lapse of data and being able to understand, like, oh, they've over-treated on A's, or they've over-treated on B's, or maybe they jumped out and did C routes too soon. We're better able to take advantage of what some people would perceive as a shortage of truck drivers or a shortage of equipment. We're better able to maybe optimize the usage of our material and our staff to say, maybe we don't need as many drivers or salt or equipment things to take care of the situation. So we've been working on some of that. That generally happens from season to season. We typically study that during the summer months, and then we go back and say, okay, these routes can be optimized. These routes can be combined with, this truck or this county. So we're doing some of that now. And of course, our goal is to do more of that in real time and get that to where it's a more regular process and identify routes that have been overtreated or undertreated and try to help with that. But right now it's all about situational awareness and pushing that data out there and trying to make that available to make those right decisions. I know within 10 seconds if someone is on a route I don't want to say that they don't belong on, but I know when someone applies salt or distributes salt in an area that may not be optimal. We know that within 10 seconds because of all of our AVL data and our ability to process that and understand exactly what route, mile point it's on, and everything else. So it's really easy to kind of flag those incidents. And honestly, it can happen. There's legitimate issues there. Maybe somebody gets confused. They find themselves on the wrong route. It's a little bit different at 3 o'clock in the morning when it's pouring the snow. Like I try not to be too critical of those people. They're doing a great service for us. So, but we do try to help them out with these type of tools and make better use of our equipment.
Great, thank you. So Chris Haas, maybe if you can share with us a little bit of like the perspective of how do you kind of figure out what's the right technology and tools and things to apply, because I think you often have people who know what their business problems are, but figuring out like the tech side of it is a little daunting. Any thoughts there on how to help there?
Yeah, I would say reach out to Chris Lambert. Reach out to your peers. Yeah, I mentioned this earlier. CDOT as well. They're all willing to share what they've done, and regardless of the technology they use, right? They're all willing to share. This is how we solve this use case. And I think that's probably, that peer network is probably one of the best ways. Reach out to us as well. We won't come in saying to you, we're traffic experts. Like, we're cloud technologists, cloud experts. We know how to process and manage data. And you are the experts when it comes to how you manage a road network and what you need to do with that. And come talk to us as far as like how you could get started leveraging cloud technology to solve the day in and day out things that you do.
I'm going to jump in on that and give a plug to our FHWA group. There is an FHWA Everyday Counts group. It's crowdsourcing for advanced operations. That group, we do a lot of discussion around Waze data, around other forms of crowdsourcing and probe data. And that has turned into a lot of this discussion about cloud computing and real-time data. That's where a lot of us ITS folks kind of meet. We have peer exchanges. And I think we've got about 30 states involved in that now. So if you're curious about that, you can jump in the FHWA Everyday Counts round 6, and it's the crowdsourcing for advanced operations group. And Kentucky is part of that, as well as a few others like Indiana DOT and some other people. So
awesome. We'll try to see if we can get some of those links included. And then we also have the Public Sector Connect community where that's also a place where different agencies can come together and share things that they've done, things that have worked, and just share knowledge across agencies. So this has been a great session. I think, what I really enjoyed about it, it's very practical and tangible, like where you start and how you go about doing it and what you get out of it. So I really appreciate both of you sharing your experiences and really creating this community of knowledge that can be shared with other agencies, because I think ultimately what we want to do is help people get there faster and not feel like they have to go through all those stumbling blocks. I think as you mentioned early on, Chris, that you all went through, you can learn from those things. So we appreciate you sharing your experiences. What I'd like to do is, as we end, maybe just ask each of you to share either, your little bit of words of wisdom, your advice, or something significant that you learned through your journey that you want to leave people with as they end our webinar today. So, Chris Lambert, do you want to start?
Don't do it. It's a trick. If somebody says big data, just run. No. It's been a fantastic journey. And I have messed up a whole lot along the way, but these are I've been with the cabinet for 23 years, and these are the best 6 years that I've had in the transportation cabinet. It's just been a blast. Find people that enjoy having fun and just turn them loose and give them some room to fail and experiment. And you may be surprised what you come up with. Like I said, it's just been a lot of fun. And if somebody's not having fun, just get them off your team. They don't need to be there. But our team has a blast doing this stuff. But and then let us reach out to us and let us know if you have problems. We do participate in a lot of peer exchanges, and we love helping other people get there, because chances are we may have figured something out and we'll help you, but we're going to come back around and you're going to figure something out that we don't know, and we're going to copy your work as well. So, but yeah, just anytime you need help or you just want to give us a call or something, just let us know. Be glad to help you all out.
Yeah, I would say big data. Thanks for leading me with that. So big data, like everyone thinks big data, like it's too difficult. I can't do it. And in the past, that's true, right? Because you had to have these big capital expenditure server racks that you needed to buy to be able to do any of that. That's not the case with the cloud. The cloud is something you could just get started with today. I mean, even if it's just, I want to use Waze data in a similar way as Chris is at Kentucky. It is very easy to get up and running in using cloud technology, leveraging just one data set like Waze. So think of it from the standpoint of a use case. Use case is just think something you do day to day and likely manually do it. And it's something cumbersome that you think you could automate. You could do it very quickly with the cloud. And I think that's the best way to get started. Just pick one thing, go do it. Doesn't cost a lot of money, doesn't cost a lot of people, resource, time, and there's obviously no investment in hardware that you need to deal with. And you can always turn it down, right? There's nothing stopping you from saying, we did it, we used it, it's either working for us, but we don't need it anymore, or it didn't work, we can always turn it back down. So it's just very easy to get started and then decide how you want to move forward. That's really how every DOT I've worked with, that's generally how they started.
Yeah, I will say I wish we had ability to go to cloud when we first started this. All of my pain was on premise, and learning how to process data. It was a bad experience. Let me go ahead and throw this out too. Google is, if we've got a couple minutes, what really impressed us with Google Cloud, and this is getting ready to sound like a Google commercial. I'm not paid by these folks or anything else. I'm a DOT employee. We were debating what to do, what platform to go with. And we called Google and we said, we don't need a bunch of salespeople handing us cards. We can find that anywhere. We need some type of technical people to talk to us and maybe put on a workshop. And they did. And I don't know if you guys are still doing that or not, but we got an entire day of like a workshop, a technical workshop where these people spent time with us on premise. This is prior to COVID, full disclosure. But we had about 5 or 6 people that flew to Kentucky and spent the entire day with us. We were there between 8 a.m. and 5 p.m. and they just, they earned it. And so we put them through the ringer. We were asking all kinds of questions, and there was a lot of technical people. We had developers in there. We had executive staff, and we just grilled them over this whole thing. And they really impressed us. That the folks there at Google just really did a great job trying to earn our business, and they've continued to do that. It's been a really nice transition to go through.
Well, thank you so much for that, Chris. And yeah, we're, we enjoy working together and that co-creation and collaboration process of really helping to identify what are the problems that you want to solve, and then how do we help you get there. And that's really, we're a very mission-oriented organization, and so we're really focused on those outcomes that matter, and that's what's important to us. And I think we all have such an opportunity here, now with the new infrastructure bill and just the new focus on these areas. And so I think there's so much low-hanging fruit that we can tackle, and then there's lots of other new challenges coming our way, that and new funding, for things like climate resilience and cybersecurity and equity and so many other areas. And so I think it's great to be able to replicate a lot of the great work that has already been done, and then also start tackling some of the new challenges that are coming our way and the new opportunities for us to reimagine transportation. So thank you all for joining today, and we look forward to connecting with you again.
Thanks, everyone.
Thank you all. Appreciate it.